Good morning, students. So today what we'll do is experiment number 4. That is, um, we initialized Kubernetes cluster in the last practical. So we saw that on an EC2 instance, which was an Ubuntu instance, all right, an Ubuntu server. Uh, what we are going to do is we are going to see the same thing. Um, So you have seen the initialization process, right? It is also given in your lab manual. So go to your lab manual. You see this initialization process we went through the last time, all right? But this was for Linux, all right? And we are supposed to do this practical on Linux, but if you do it on Windows, it will be the same thing. Uh, After this initialization of your cluster, that is after you, sorry, I went too far. Yeah, after your um, node has joined into the cluster, and you can after you can see that node in your uh, cluster, what you can do is you can make a new application, all right, that you need to be hosted on your uh, cluster. Okay, so basically any Docker container or a containerized application that needs to be managed. All right. So we have seen what Kubernetes actually is, right? It is a container management service. So it does not create containers, but what it does is it manages containers made by all other technologies. All right. So be it Docker or any other container management service, and we have seen the architecture of how it does that. Okay, so it has these processes which work on the master node and some processes that run on the uh, client node or the worker node. The main processes that are concerned is the API server, which is API server and the control manager on the um, master node. Well, each one has a specific task, so we cannot say that one is more important than the other. But on this worker node, we have the kubectl, uh, sorry, the kubelet process, which is very important because all communication between the worker and the server node happens through kubelet. All right, so anything that the master wants to convey to the worker node, or if it wants a pod to be spin or a deployment to happen, that all happens through the kubelet. All right, so now what we'll see is how to actually do this thing um, on Windows. All right. So basically, the installation process part. If you see, I've already included a video which will show you how to install Kubernetes on Windows. Over here, you can see install Docker Desktop with Kubernetes over here, and this has only one step. So I'll just remove this. Okay. Okay, I'll keep it as it is. All right. So if you go to this link, this is a video, YouTube video, which will show you, guide you through the installation process for Docker Desktop. Basically, you just have to download Docker Desktop. So if you just type in, sorry, if you just type in Docker Desktop, all right, and maybe download, you will be taken to this page where you can just simply download Docker for Windows. All right. This has some dependencies. It requires Windows subsystem for Linux. All right, and it requires virtualization to be enabled. So your hypervisor uh, should be enabled for this. If you have ever installed VirtualBox, or if you have VirtualBox installed, don't worry about it. It just simply means that hypervisor is already on. But if you don't have, please check whether your hypervisor is on. That the process for enabling it is also given in that video that I've sent. You can just double click on this Docker desktop installer. Just go through a series of steps, which basically required for you to click on next, nothing else. All right, just click on next. Don't worry about it. And after that, after you run it for the first time, it will ask you. It is supposed to download Windows Subsystem for Linux. That is WSL2. But alternately, if it doesn't, what it will do is after you run it for the first time, it will give you a link where you can download that Windows Subsystem for Linux. So just click on that link, and I guess that will be yes. You can see over here WSL update x64. This file will be downloaded. After you download this file, you have to run this file, and then that's all. All right. So Docker Desktop is very simple to install on Windows. After that, what you'll probably need is to restart your PC, and then over here this whale icon will appear. If you right click on it, it will give you all the preferences, the settings that you can play around with. Okay, just go to the settings and enable Docker. Sorry, Kubernetes. Okay, so yes. So here we are in the settings area. Just go to the Kubernetes section, and over here, this won't be enabled when you install it fresh. So just click on these two icons, these checkboxes. Just tick these checkboxes, and then click on this apply and restart. Okay. After you apply and restart, Kubernetes will be installed, and the cluster will be initialized. All right. So you'll have a default Kubernetes cluster which is already installed. You can see over here it says reset Kubernetes cluster, which means that there is already one uh, Kubernetes cluster which is available. If you want to reset, you can just reset that cluster. Okay, and the same can be done in Linux by init command. All right, so let me just show you that init command. Here, this kubeadm init command will initialize the cluster, and if you want to reset, which was that red icon, that red button over there, that is done with this command, that is kubeadm reset. All right. So in Windows, you just have to really click on buttons, and that will do your job. The reason why I'm showing this, the next practical, that is creating a deployment and this running this application on Windows, is because couldn't get the engine server to show output. All right, so it was running, it was deploying. All these things were created. That is, it was able to scale up, scale down, everything that we'll see in this practical. But I wasn't able to uh, see it on a public IP address. Okay, so I wasn't able to capture when I captured the public IP address and just um, what I did. when I tried to view the output, it was not available. So that is the reason why I'm showing this our next output on Windows system, okay, on local server. That is a local system, all right, not on a cloud system. I'll anyway, what I'll do is I'll just log in to my AWS account, maybe uh, start up the servers. So if you have time at the end, we'll just look uh, whether it runs or not. All right. I'll just start the servers and then we'll move on with our actual practicals. Okay. So just start this instance and we'll keep it in the background. Okay. So this is not required. All right. So in Windows, what you'll need to do after you install Kubernetes, okay, if you just right click, sorry, if you just right click on this icon and go to Kubernetes tab, you will have this context available, okay, which says, which has default context, that is Docker desktop clicked. All right. Now, what context is? Uh, it's a binding. All right. Basically, a binding between a user and a cluster. Okay. So in your Kubernetes, so let me see whether I'm able to view it. So in C users, uh, administrator, cube, and this config file. Okay, this is the basic configuration file, the default configuration file. In this default configuration file, if I just open it with Notepad++, you'll be able to see various things that are given over here, right? The configuration of the Kubernetes. All right. All right. So over here, you can see the API version is set to version 1. There's the information about the cluster. So there is a cluster that is already defined, and that cluster's name is Docker Desktop. So you can verify that the name is in fact the same when you see the Kubernetes. You see that this is Docker Desktop, right? So we have this Docker Desktop cluster, and then we have this users. All right. So users is what users are allowed to use this. What users are available for this Kubernetes installation. All right. And then the name is Docker Desktop again, and there are certain credentials that are attached to this user. Similarly, there are certain credentials that are attached to the cluster. All right. And what uh, binds these clusters and these users together is what is called as context. All right. So a particular user is allowed to access a particular cluster. All right. And that is defined in this context. All right. So you can see over here in context, we have cluster Docker desktop, which is able to use the user Docker desktop, which is able to use the cluster Docker desktop. All right, and the name for this context that is binding these two users and clusters together. That is this pair of cluster and users together is also known as Docker desktop. All right. So these are generated by default when you create a Kubernetes cluster in Windows. Okay. So this is what combines these files together, and the current context you can see. The current context is set to Docker desktop. So whatever commands will run, it will be run as this context. So it will use this user and this cluster, all right, for running all the commands. Okay. So kind is configuration. So basically this is all that is available in the config file. Okay. So this is something you should remember. What is context? Basically, it is a binding between the clusters and the users. All right. So it specifies what user can access what cluster. All right, and it also has a name of its own. So if we want to modify this context in future, we can just address it by this name and then change the cluster or the user associated with it. All right. So this was the basic settings. Now let us dive into the uh, practical part. I see that I have not included this context part over here. Anyway, if you want to install kubectl on Windows, so basically after you have installed Kubernetes, okay, which I briefly said how to do it, you just install Docker Desktop and then enable Kubernetes, and that will install Kubernetes. So after you do that, you go to this URL. This URL is the um, official website for kubectl installation. Okay, this is a Kubernetes website. Over here, you will see the version, the latest download release version over here. If you click on this, you will be able to download the binary file. All right, I'll just cancel this because it is already present. So just take this exe file that is downloaded, kubectl.exe, and paste it and go to C drive, create a folder called kubectl, okay, and just place that file inside this kubectl folder. All right, so this is the kubectl.exe file that I downloaded, and I just pasted it inside this folder. All right, so what that will do is it will allow you to use the command line. So I basically forgot to tell you what kubectl is. Kubectl is basically the command line tool for Kubernetes. Right. So when you want to access Kubernetes via command line, after you have initialized the cluster, initialization, as you have seen in the last practical, is done with the tool called ADM, KubeADM, right? So we installed these three components on Linux: kubelet, kubeadm, kubectl, right? One of these is the command line tool. This is the administrative tool, and kubelet is the basic process that runs on both server as well as the worker node. All right, so this is the basic process that carries out all the activities. Okay, and this Kubernetes CNI, I forgot what this was. Anyway, uh, after you have installed that, that is after you have installed kubectl, what you'll do is you can either download this from here and just paste it in the C drive, which is a simpler version, or you will what you can do is you can just play around with the PowerShell. You can just open up uh, Windows PowerShell as administrator, of course, right? And then you can just run all these commands. Okay. So what this does, the description is already given against all these commands. So you'll just get the execution policy. You can see that for the current user, that is the administrator current user, I've changed the policy to unrestricted. Okay, and that is because I want. Okay, this should be remote. What remote? Remote signed. If you want to execute any remote scripts, all right. If you want to download scripts, so basically what we are doing over here is we are seeing we are looking at what all policies are there for the users. All right. So what all policies are there? So for current user, the policy initially will be undefined. So what you'll need to do is you will need to change the policy to remote signed. All right, and what that will do is it will enable you to run remote scripts and also download those scripts. Okay, so you'll just after that you'll be able to run this command install script, and the script name will be install kubectl. Okay, and that you will run the script, and you will store the output in this folder, which is basically the folder that we created. All right, and then if you just run this command kubectl version, you can also run this on command line. All right, that is your cmd. Okay, it's not necessary you run it on PowerShell. Uh, the That is kubectl commands. Okay, so once you have installed this, you can just open up a simple command prompt. I'll do it as administrator because I want all the privileges. And just if you type in kubectl uh, version hyphen short, you should be able to see the client version as well as the server version, and that those two should be the same. All right, because if they are not, they will cause you some trouble. All right, so these you should be able to see. All right. Okay, so after you do that, what you can do is you can run this command, that is kubectl get nodes. What that does, kubectl get nodes. What that will do is it will get you. It will list out all the nodes that are present in the cluster. Okay. Now, if you remember, we ran this same command. This was the last command on our Linux installation. All right, and there we were. I think I demonstrated that. I don't remember it, but there, if you run that command at the end, you will be able to see two nodes. That is the master node and the slave node, both in the current cluster. Okay, this is taking too much time. All right, it gives us the nodes that are present and the details. So you can see the Docker desktop is present, and it is the master node and the version and age. All right. So it is installed from 7 days, 18 hours. 7 days and 18 hours. It's running over here. All right. Then uh, these commands are actually used to clear up everything that you have created. So we'll see those last. Uh, then what you need to do is you need to create a deployment. All right. So what is a deployment? All right. So deployment is basically it defines what you want to do, what you want to have in your cluster. All right. So say in my cluster, what I want is that 10 processes, all right, or 10 servers should be up all the time. All right. No matter what happens, 10 servers should always be running, or 10 processes or 10 kubelets, or what you call 10 containers should always be running. All right. Uh, what happens if consider this scenario where you have two masters and four worker nodes, and one of them crashes. All right, so this last one crashes. So observe that in this scenario, there are three pods that are already running. All right, three pods containing containing containers, and which are serving real-time traffic. All right. So what should happen in this case is that it will of course be observed uh, by the master, right? The HCD storage will actually the control manager will actually detect the change and will make the corresponding change in the HCD, and then tell the scheduler that these three are no more available. So what should happen is these three processes should automatically be assigned somewhere else. All right. So what will happen is the scheduler will look at the minimum usage, and based on that it will either assign it to some of the servers, or it will spin up a new server entirely. Okay, spin up a new server, and or use a server that is kept in what you call backup, and it will assign these processes to that backup server. All right. So this process should happen automatically, the assigning of uh, assigning of the processes that are already dead. Okay. For that, you have to specify what number of processes there should be ideally present at a given time. All right. And that configuration is actually defined in something called as your deployment. Okay. So deployment is uh, uh, a Kubernetes object in which you define the desired state of your cluster. Okay. Maybe I should have started with that. Anyway, so it is where you define your desired state of the cluster. All right. So you define that you should have these many um, pods, or these many containers. It should have these ports open and all those things. All right. So uh, it should have these replica sets. All right. So that is where you define uh, your desired state. All right. And that is what we are going to create here. So here, you can just read through the description. It says a deployment is a type of Kubernetes object that ensures there's always a specific number of pods running based on the defined template. All right. Even if the pod crashes during the cluster's lifetime, the above deployment will create a pod with one container from Docker registries, Nginx. Okay, Nginx is uh, given over here because we have actually created a deployment based on Nginx image. All right, so basically any Docker image, all right, that we specify. So what deployment does is it takes the desired state, and what Kubernetes will do is it will check the deployment to see that whether the desired state is always met. If there are unavoidable circumstances, then it will if it is unable to get that um, desired state, it will remain in the not desirable state, but it will always try to achieve that desired state. All right. So that is the work of that is how Kubernetes works. All right. So over here, what we are doing is we are just creating a deployment. We name this Nginx, and that is based on the Nginx image, which is available in the Docker Hub. So if you just go to Docker Hub, over here, if I just type in Nginx, right? Okay. Nginx, you can see it is a web server basically. It's a powerful web server that will host all your applications. All right. So this is the image that we are basing our deployment upon. Okay. So what we'll do is we'll just copy this command and run this command. Okay. Okay, I'm unable to paste it. So I'll copy it again. All right. So basically what we did is create a deployment. So kubectl create deployment Nginx and then image on which it is based. All right. So now if we just check the deployments, which is kubectl get either deploy or deployments. Okay. So you can also use deploy over here. I'll just copy this. Right. It does the same thing. What you will get is the number of deployments that are present and what is the status. So you can see that there is one deployment named Nginx and that is ready and up to date. All right. All right. And its age is 23 seconds. All right. So now we'll move on to a service. So what is a service? We'll just read through the description to avoid the awkward explanation that I give. So services are another type of Kubernetes object that expose clusters internal services to the clients, both internal and external. They are also capable of load balancing requests to multiple pods and are an integral component of Kubernetes, frequently interacting with other components. So basically, what service does is it provides it creates a service. All right. So it basically in if you look in the diagram, what it will basically do is it will create a uh, pod on this worker node. All right. Now as we are doing this on our Windows system. All right. So Windows system is acting as the it has it is it has both the components installed in it. But if we separate these two, that is if as we saw in the previous practical, if we separate the master node and the worker node, that is if they are available on two different servers, then what you will be able to do is you will able to see that the pods are actually created only on the worker nodes and not on the master nodes. All right. And that is because master node is only responsible for managing the cluster and not for running the pods and running the pods which are serving traffic. All right. Or deploying your application on that. So over here, so what service will do is basically it will create obviously it will create a service which will expose this port that you specify. All right. And if you access it will create a random port that will be assigned uh, by Kubernetes. All right. And on that port we'll be able to see our output. So if we just copy this, uh, the command says kubectl expose deploy Nginx, which is the deployment name, and then we specify the port number as 80, and the target port number is also 80, and the type is node port. All right, so a node port will be assigned for our service, and when we paste this command, it will say that the service that you specified is created. Okay, so service engines is created. Now if we want to see our services, the command will be simply kubectl get services. Wait, something went wrong. Kubectl get services. Oh, sorry, kubectl. All right. So if I run kubectl get services, it will show us that there's a default service which is the Kubernetes cluster Kubernetes cluster which is running, and then there is this engines service which we have created just now. All right, and it is available on this port. Okay, internally. Externally, we have to enable incoming traffic, and then we'll be able to access it through this port. All right, or I guess this is available only on this traffic. So we'll see. So in order to view our output, what we can do is we can just copy this IP. All right, I'll just copy this IP. Go into our web browser, open up a new window, just paste the IP address and the port number. So port number is 30285. So 30285. And when I click enter, HTTP colon this. It is taking time. Okay, site can't be reached. Maybe we can reach it through localhost. Yes. So when we access it through our localhost, since our worker node is actually our local host. So what we can do is just write localhost over here, and then the port number, and that should bring us our welcome page, which is the Nginx installation page. All right. So that which means that our service is actually running. So this actually should be running. I don't know why this is not running. Yes. Oh, yes. I'm. I. I made a mistake. This is not actually the. This is the cluster IP. Uh, what you should look for is the IP address uh, of your node machine. All right. So if you see over here, the Ethernet IP address, IPv4 is this address, not that. All right. So 192.168.10.164. If you just replace this, which is nothing but our local host, all right, then we will be then we'll also come back to the same page because that is the local host IP address. All right. So we have now created a service. All right. What we need to do is we'll see how to scale up and scale up that service. So we have a running service. All right. If we check our running containers, so Docker PS, this command is covered in your Docker experiment. If you, we'll see that there are multiple processes that are running. The first process it shows up is the Nginx service, that Nginx container that is created just now, right? And then there are various other containers which are running. Okay, there are container IDs attached, and there are names attached to them also. So there's Kubernetes pod for Nginx. I don't know what this is, but it says controller somewhat. This is a storage provisioner, proxy for Kubernetes, core DNS. All right. So there are various. There's the scheduler. So you can see that every object that we covered is basically a pod uh, which has this containers running on top of that. All right. So you can see there are these containers which are all running in the main process. Okay. You can see the HCD also has a container. All these containers are all present on the master node, uh, itself, and there may be some of them which are also. Most of these services are from masternode. There might be some which are also. There will be a kubelet for the uh, client machine, that is the worker machine, but I don't know how to recognize it. So anyway, uh, you can get the pods by just writing kubectl get pods. All right. So you can see that there is only one pod running, which is the Nginx pod, which we created just now. All right. That our deployment, the service ran. Okay. If you can see there is only one uh, instance of it, and if you want to scale it up, we'll just scale it up using this command. All right. So that's kubectl scale hyphen hyphen current replicas. You can specify the current replicas and the replicas that you want, and the name of the service that you want to scale up. All right. So okay. Okay. Scale current replicas hyphen hyphen. Okay. Run half of the command. Current replicas equal to 2, replicas equal to sorry, 1 equal to 2, and then we have the name of the service that we want to scale up. All right. So deployment, sorry, the deployment that we want to scale up, deploy hyphen name of the, right. uh, empty deployment hyphen engines. All right, so the deployment that we want to scale. All right, so it says at the end that it is scaled. So we'll just check for the pods that are available, and you can see that there are 2 pods available. All right, which means that our service is already scaled. Okay, if you want to scale down this service, you can simply use that same command with the number of replicas changed. All right, so instead of 1, you'll write 2 over here, and the current replicas you want 1. Just change it and then check it again. You can see that this is not ready, which means it is terminating, right? And now if I just check it again, it will be gone already. Okay, so this is how you can scale up and scale down your services using Kubernetes. All right, uh, now this all the other processes are actually to uh, cleaning up processes. So first I'll show you how to describe a deployment. Okay, so you can use not only for deployment, but you can use this describe command for your various objects that are created in Kubernetes. All right, so if I just click on describe this deployment, what it will do is it will give us all the information. So you can see the name of the deployment, the default, the namespace that it uses. Namespace is basically uh, the name associated with that uh, series of objects. Okay, so if you don't assign anything, it will be default. If you create, you'll have to create a new namespace, and then you can attach it to various deployments. So what that will do is it will if you specify if you create a specific namespace and just do um, uh, activities on that namespace, so it will be separated from all the other it's a basically it's a way of separating your processes. Okay, so if you want to separate, say, your development server, your development processes from your deployment processes, and then your production services. Okay, so for different teams you want different names, you'll create different namespaces and then assign different um, deployments and different services to those namespaces. All right, so that is how you will differentiate using namespaces. Okay, so you'll see various information regarding here. The desired state is 1, the updated is 1. All right, available is also 1. So here you can see the desired replicas is given. Then the image on which these containers are based. All right, the pod template, that is the container information on which this deployment is based. So the image is engines. We haven't specified anything for ports, right? Then you can down here you can see all the events that have happened. All right, so this was initially one when it was created. Uh, sorry, yes, when it was created. Uh, from 0 to 1, right? Then it was scaled up from 1 to 2, and then it was again scaled down from 0 to 1. Sorry, 2 to 1. Okay. So all these events are also given. So you can just go through what changes have happened to your deployment at a given time. All right. So what I'll do is I'll just enable the attendance form. You can mark your attendance side by side. All right, and what remains is just to show you the cleaning up process. So that will be, since we have created a service at the end, we'll just delete the service first. That is bottom up approach for deleting, top down approach for creating, and bottom up approach for deleting. All right. So CLS, we'll just delete the service engines. It says deleted. We'll just verify that it services. Okay, so you can see there is no engine service which is present over here. Then what we did was created a deployment. So we'll delete the deployment engines. I'll copy this command, paste it over here. It says it has deleted. Now what I want, yes. So if you see, if I get all the deployments, it says there are no sources in the default namespace. All right, and since we have not created any namespace, it's not. It doesn't matter if we check the to check the other namespaces because there are none. All right. You can just, I guess, you can get namespaces also. Okay, here you can see you can get the namespaces. So this default is the one which is selected by default. Then there are these which are actually used by system. Okay, created by system. We can also create our own namespaces for, as I said, different teams that we want to separate. Okay. Before creating a deployment, what we did was uh, uh, we could see the nodes that are there. All right, there's only one node attached in this case. So if we were running this same thing on a Linux container, it would show us two nodes over here. All right, and in that case, what we would have to do is we would have to first drain our nodes. All right, the node to be removed, which would be our worker node. So draining, what will do, it will remove the traffic from all the um, that goes to that node. All right, and then we'll delete that node. Okay, from the cluster, and to reset this cluster, the command is kubeadm. I guess I did not include it over here, but it is included somewhere over here in it. Yes, you can see in the previous practical it is included kubeadm reset. All right, so this command you will run if you are running it on Linux. Okay, if you have two EC2 instances that are running separately, one as a worker node and one as the client master node. So if we just refresh this page, it will show that it is not available anymore, right? Because we deleted that service. All right. So this was regarding the practical number 4 for Kubernetes. That is how to spin up a service in Kubernetes using deployments and all those things. All right. So if you have any doubts, you can ask right now. Otherwise, if you have marked your attendance, you can simply exit out from this meeting. All right. Thank you for joining. One more thing, I will be posting the assignment for this. That is the write up in the classroom. So watch out for that.